we're going to solve equations that involve a radical. So to solve radical equations, okay, step one, you need to isolate the radical. On one side of the equation. Step two, square each side of the equation to eliminate the radical. Step three, check the answer. Okay, so for example 1, we have 2.5 equals the square root of h over 4. So since this is a division problem, we know that the opposite of that would be multiplication. So I'm going to take my 2.5 with square root of h over 4, and we're going to multiply both sides by 4. 10 is equal to the square root of h. So we've isolated the square root on one side of the equation. Now we need to square both sides, and by squaring both sides, we will eliminate the radical sign. So this becomes 100 equals h. All right, now we're going to check that answer to see if it actually works. So check. We take 2.5 equals the square root of h over 4. 2.5 equals the square root of 100 over 4. 2.5 equals 10 over 4. And when we divide 10 by 4, we're going to get 2.5. Check. So that answer works, and that would be correct. All right, next one. Okay, second example, we're going to take the square root of x plus 1 is plus 7 is equal to 10. All right, now we want to isolate the square root, so that means we're going to have to move the 7 to the other side of the equation by adding its opposite. So now we have the square root of x plus 1 equals 3. Now you're going to square both sides, and we would have x plus 1 equals 9. Subtract 1, x is equal to 8. Now you need to check that to make sure that it works. So we're going to take the square root of x plus 1 plus 7 equals 10. The square root of 8 plus 1 plus 7 equals 10. The square root of 8 plus 1 is 9, plus 7 equals 10. The square root of 9 is 3, plus 7 equals 10. 10 equals 10. Check. So x equals 8 is a solution to that radical equation. All right, a couple more. If we have the square root of negative x is equal to 5. All right, so it's already isolated, so we're going to take this and square both sides, and we'll get negative x is equal to 25. Well, we know there's a negative 1 in here, so we have to divide by negative 1. So x is equal to negative 25. So now we're going to check that one. So I'm going to take my equation, my original equation. So the negative x equals 5. The square root, now that negative sign is there, but my x is actually equal to negative 25 equals 5. So we know that a negative times a negative makes that a positive 25, and the square root of 25 is 5. Check. So x equals negative 25 would be correct. All right, last example. We have 3 square root of 7 equals the square root of x. Well, the variable and the radical is already isolated, so we're just going to go ahead and square both sides. Now, when we square both sides here, when you square the 3, it becomes a 9. When you square the square root of 7, then that's going to disappear, and that's going to become times 7 equals x. 63 is equal to x. All right, so let's substitute. 3 square root of 7 equals the square root of 63. So 3 square root of 7, we would have to take that square root of 63 and break it down to 9 times 7. 3 square root of 7 equals, the square root of 9 is 3, and 7 stays inside, and that would be check. 63 would be the correct answer.